Hello there. Welcome to the Augmented Engineering Drawing course. My name is Pilani Biela and I'll be your lecturer and facilitator. In this course, we'll be going through the journey of learning the basic skills of technical drawing, which will be very valuable in your journey in becoming an engineer. Now, technical drawing is a form of technical communication and information. As a student who has just completed matric, the two main forms of communication that you are familiar with is through the languages that you've learned at school, and the form of technical information that you are most familiar with is through mathematics. Mathematics, there are a set of rules, set of steps that you follow in communicating mathematical solutions through equations. And this form of technical communication, you further apply it in the field of physical science, in the physical sciences, to solve problems that you encounter in the physical world. Now, in technical drawing, it's also a technical skill, a technical form of communication. And where you'll be using it is in designing and manufacturing. You see, as an engineer, you'll be using mathematical and scientific knowledge to solve real-world problems. And the way in which you present your solutions in solving these real-world problems is through designing the solution and actually manufacturing it. And the most effective way of communicating your solution design and the specifications through which your solution needs to be manufactured is through communicating them technically in the form of a technical drawing. Now, as an engineer, depending on the field, I mean, in all engineering fields, technical drawing is necessary. As you can see, mechanical engineers will be using their technical drawing skills to draw mechanical engineering-based solutions. Civil engineers will use their technical drawing skills to design bridges and other civil-based solutions. Chemical engineers will be using the technical drawing skills to communicate chemical processes. And electrical and electronic engineers, as they will be working with electronic systems and designing electronic systems, they will be required to communicate these through technical drawing as well. Now, just like in any form of communication, there are rules and standards that need to be followed. The reason why there need to be rules and standards is to ensure that when a chemical engineer sees a mechanical drawing, they should be able to interpret what it means. It's to ensure interpretability and ease of communication across the fields. And technical drawing is important for all engineering disciplines. To just help you understand this with a typical example, if you look at the chemical process plant that is at the bottom, this is an oil refinery. An oil refinery is a very large and complex system. And in the construction and the design of an oil refinery requires the expertise of all forms of engineering. Firstly, if you look at the structures, civil engineers are needed to build the structures that will be used to process these chemicals. Mechanical engineers will be involved in building and designing and constructing the mechanical equipment that will be used to transport chemicals and process them to produce the final product. As you can see, there is electricity involved. Electricity to provide power to the mechanical equipment and also lighting to the plant to make sure that it is safe and operable. And electrical engineers are needed for this. Now we live in a digital age where a lot of systems are automated, and in process control and optimization, electrical engineers and computer engineers, they design the systems to automate and provide control to these processes. So as you can see, in constructing this plant, it needed the expertise of all these engineers. And how do they communicate with each other effectively? It is through following a similar set of rules and standards. This ensures that in constructing this plant, a chemical engineer is able to interpret the design of an electrical engineer, and the electrical engineer can interpret the design of a mechanical engineer, enabling them to employ their expertise and add value to the final product. And that is why a technical drawing is a skill that is important for all engineering disciplines. Later on, in the second semester, you'll reach a stage where you're going to be building 3D models, and the skills that you're going to be learning in the augmented engineering drawing course will be valuable in helping you have the fundamentals for you to develop these complex 3D models at a later stage. Now, when we look at the augmented engineering design course, a drawing course, the aim is for you to develop basic information skills to be able to read and understand drawings as a language for engineering communication. As I've said earlier, technical drawing is a form of communication. And just like any form of communication or any language, you're going to need to learn how to read it, and you're going to need how to understand it. And most importantly, you're going to need to learn how to write it. And in this course, that is what you're going to be learning: how to read technical drawings, how to understand technical drawings, and how to develop your own technical drawings. You've also developed the fundamental principles of projection and drawing practice. Now, in industry, there are standards, there are fundamental principles that are followed worldwide when communicating through technical drawing, and you are going to learn these fundamental principles. The module content includes the concept of first and third angle orthographic projection, which is a form of drawing in where you present an object as if you're looking at it from a 90-degree angle. Then we'll also look at isometric projections, which are more pictorial representations of objects. And we'll also cover aspects such as hidden detail and dimensioning, how to dimension your drawings to communicate the size and perspectives. Also, you will be exposed to other forms of conventional representations, which include auxiliary views and development and interpretation. Now, in this course, all these concepts will be applied in a computer-aided software tool, which is called AutoCAD, and you will need to have access to, you will gain access to this software tool for you to participate in this course. Now, why are we using AutoCAD? Of course, there are different types of drawing. There's instrumental drawing, which is in the form where they use instruments on a drawing board. Then there's computer-aided design. That's what CAD stands for. And another form is sketches, which you're probably more familiar with if you like to drawing at school. Now, the good thing, the advantages of us using the Autodesk AutoCAD software is that, firstly, it is an industry standard. It's a software tool that is widely used in industry. So that means you will have this, once you get into industry, you will have the fundamentals needed to be able to perform drawings and do any other form of technical drawing using the tool. It also has a very high accuracy and precision compared to instrumental drawing and driving and doing sketches, which is important because once you're working with real world projects, there's a lot of money and time and resources involved. And the higher the accuracy, the higher the precision in which you can produce your drawings and your designs, the more valuable it'll be for the company. As well, it is a very comprehensive editor-friendly tool where you can actually undo, redo, and modify your drawings in a seamless manner without having to restart your drawing or having to sort of erase wrongly drawn lines physically as you would in an instrumental or a sketch. And AutoCAD is a software where, as you continue, especially in your final year design project, you're going to have to draw your final design, and AutoCAD is the tool that you're going to be using to do this. So it is very valuable that you master it and you learn it, and it is something that we are going to be doing in this course. Now, just to go through the module structure. So the module structure is split into lectures. So lectures will be online. They'll take place weekly, every Friday. and that information will be available on the Moodle, on the Moodle page for the course. It's usually on Friday mornings where we have the lectures, and then after each lecture, you're going to have a tutorial. And the aim of the tutorial is to evaluate, is to help you practically understand a particular concept that has been learned in a lecture. So in a tutorial, you will get a drawing that you'll have to do, and it will be based on the concepts that you've learned in the lecture. Now, as part of the engineering CASI program, we do have supplementary instruction, and you'll have a SI leader, and this person is there to help you with extra exercises, to help you sharpen your skills in technical drawing. There will be a dedicated day and time during the week in which the SI leader will meet with you on an online basis and go through whatever challenges or difficulties that you may be facing in your course, in the course. And then finally, we will have tests. We will have 3 main tests, and these main tests will cover all the different topics that will be covered through the duration of the course, and these will add to your final result. Now you may ask yourself, how do I perform well for this course? So the first advice I'd like to give to you is that attend all your lectures. In the lectures, we give a concise description of concepts. We go through a lot of examples, and these will be valuable in helping you develop an understanding of the field of technical engineering drawing, and also on how to use the AutoCAD software. I'd also advise you to attend all your tutorials, and not only attend them, but also complete the tutorial questions in your tutorial session. The tutorial is there to evaluate, to help you evaluate whether you understand a particular concept, and whether you're able to apply a particular concept that you've learned in your lectures. Another thing is ask for help. I know many of you students at high school, you used to do well. You could just sit on your own and understand a concept and do well. But in university, you're going to learn a lot of new concepts, a lot of new ideas. And one of the most effective and fastest way of grasping this concept is not to be afraid to ask for help whenever you're really stuck. Another important point is that you should practice until you get it right. Initially, it's not going to be straightforward. Just like when you run, if you want to run 10 kilometers, you don't just start 10 kilometers. You usually start at 2 and then you ramp up. It's similar with learning. You'll be introduced to new concepts. You will not master them immediately, but through practice, you will eventually master them and develop a very proficient skill set in the concepts that we will be covering in this course. As well, repetition is the mother of learning. Always, repeat, revise through your work to ensure that you understand all aspects of a concept or a subject that will be presented to you during this course. Another important or valuable piece of advice that I can give to you is that make use of the available online resources. Yes, we will be doing a lot of practical videos, and we'll be explaining concepts comprehensively in our lectures. But then also, if you want to broaden your understanding or develop, a next level understanding of particularly using the AutoCAD software, I'd advise you to watch YouTube videos. Many of them are available to help you to work faster with AutoCAD, and they will present other shortcuts that will be valuable in speeding up your ability to perform your drawings. And lastly, attend SI sessions. SI is there to support you because we understand university is a very different environment compared to how it was at school. So we have the supplementary instruction is the support structure to help you solve your problems or issues in certain aspects that you do not understand, and they will be very valuable in helping you become a proficient technical drawing student. Lastly, I thought I'd just share the slide of what happens without good technical drawing fundamentals, and hopefully at the end of this course, you'll be skilled enough that when you get into industry, you will never make such mistakes. And I really look forward to working with you guys and building you up to be very good technical engineering drawing students. Thank you very much. We'll see each other in the future lectures.